Hello. Now we're going to talk about the difficult pain in the SSA situation that occurs when we want to solve an SSA side-side angle or ASS. So when we look at solving a triangle where we know two sides and a not included angle, so this is different than side angle side. We use law of cosines, and that comes up in our next section. So if we're trying to deal with an SSA triangle, we have 8 cases that we must consider. We have 5 cases that occur when there is an acute angle given, when the angle given is acute, and then 3 situations that could occur when the angle given is obtuse. So remember, an acute angle, acute little teeny tiny angle is between 0 and 90 degrees, and an obtuse angle is going to be between 90 and 180. So suppose that we are given a triangle ABC. In all of these situations, we're going to be given a triangle ABC, and the two sides given are B and C, and the angle given is B. And what that looks like, and I just see a typo there. Let's just cross that out and pretend like it's not there. So what we are dealing with is we might have a triangle with sides C and B. That would be angle B. If I were labeling my other angles, that would be C. I'd call this guy up here A, which would make this a little a. Okay, so we're dealing with a triangle, and we are going to be considering the fact that we are given angle B and that we also know side C and side B. So that gives me side-side angle, SSA, or angle side-side. All right, and that's the situation that we have to think about a little bit specially. So for example, we could be given an angle which is an acute. Okay, an acute angle is given. So in this situation, I'm going to start us off with just some triangle. And suppose we've got this angle B here, and side C, which is this one, is bigger than side B. It's too long. So it's acute, but we could end up with a situation where this does not make a triangle, where B is too short to reach this base. Okay, so that's what that looks like. Now, again, we could have a situation where B is shorter than C, but just long enough to reach down here. Okay, so what would that look like? We still have our same situation. I've got my angle B. Side C is longer than B, and B reaches down just enough to where it can touch. And in order for that situation to occur, it's just reaching, it's perpendicular to the base, and we have a right angle. So the example above, B was shorter than C, but too short to reach the base. Here we think about that dangling arm B, and maybe if it's still shorter than C, but just long enough to touch. All right, this is the situation where we run into two solutions. So again, we're dealing with this acute angle B. So we've got our acute angle B. We're still calling this side right here C. And B is shorter than C, but it's just long enough to reach. And if I swung it, it could reach in 2 places. So this is our 2 solution situation. We would have this angle right here, this triangle, as well as the larger triangle. Let me use a different color for that. So this larger triangle. So we have the smaller inner triangle and the larger triangle. So we're thinking about this, and we're saying that this side B right? We drew B, we said, okay, well, it goes down right here. Well, if I swung it and changed that angle, but still kept it the same length, it creates two triangles for that side length, okay? So the main point, and we still have, two more acute triangle cases and three obtuse triangle cases to discuss, but the point is we can have two solutions, all right? And that's what we want to be remembering. So now we'll consider case 4. And what case 4 looks like is we have this situation where we have angle B and side C. And B, side B, which is opposite angle B, happens to be the exact same length as C. So even if up here it swung, so even if I took that and I swung it around, it would stop right here. So it only forms one triangle, and that would be an isosceles triangle. Case 5 is one solution. So the way this one works, I have still angle B, I have side C. And in this case, side B is bigger than side C. It's longer. So maybe it's longer to the point where it comes out and touches my base right here. I'm trying to make sure it looks longer. So if I took this side of this length and I swung it around, because remember, we don't know this angle measure up here. If I swung it around, it would actually come over here, and that does not create an alternate triangle. So in this situation, there's only one solution. All right, so when that B side is longer than the given C side, that would be a one solution case. Okay, again, so thinking about rotating that at this pivot, it would end up somewhere over here, and that would not create another triangle. We also have our three obtuse cases, and I've got my pictures pulled in here. So this is saying that we are given an angle B which is obtuse or greater than 90 degrees. So the first case, side B is shorter than C. Side B is too short to ever reach this base. No solution. Side B is equal to side C. So these are the same length. And if I think about rotating this around or through here, it would cross right at that angle B, and we wouldn't have a solution. So again, no solution. So really the only way it works when you're dealing with an obtuse angle is that side B must be of some length longer. Doesn't have to be that much longer, but it needs to be a little bit longer than C so that it can come down and touch somewhere on that base. Again, we don't know the side length of this base, so it could be touching anywhere. All right, and in that case, we have one solution. The main takeaway from this is if you're dealing with side-side angle, and you have an acute angle here, there is a possibility for two solutions, and I recommend that you just always consider that possibility for two solutions. I do want to point out you've probably got a very nice applet in your My Math Lab homework, which will allow you to kind of see these different cases. And if it's not built into your homework, which I'm sure I would have built it in there unless Pearson took it away from us. But if it's not built in there, email me and I can find you something if you really want a stronger understanding of this visualization. As always, email me if you have any questions. I'm going to do an example of this in the video which follows. Good luck.